Hello and welcome. This video is on one of the effects of a force, and this effect is referred to as the turning effect of a force. The turning effect of a force. We studied the topic turning effect of a force in Form 2, and in that topic we've got various subtopics. What are they? We usually start with the definition of moment of a force about a point. Then we go to calculating moment of a force about a point. Then we look at factors affecting moment of a force about a point. We look at the principle of moments. Then we look at problems on the principle of moments, followed by parallel forces, moment due to parallel forces. Then we look at something we refer to as a couple, and then moment due to a couple. Now let's go straight to the definition of the term moment of a force about a point. But before we go there, I'd like to state that before you look at this topic, you have already looked at the concept of force as either a push or a pull, and then after that you've stated the SI units of force as Newton, and then very importantly you have looked at the various effects of a force. As a matter of fact, in examinations you may remember a question like state maybe 2 or 3 effects of a force, and you may have stated that a force can make an object which is stationary to start moving, or one which is moving to either move faster, slow down, change direction, and so forth. In other words, a force can affect the motion of an object. That effect is studied in Form 3 under Newton's laws of motion. You may also have stated that a force can change the shape of an object. That effect is studied in Form 2 under a topic referred to as Hooke's law. A force can also exert pressure, and you studied pressure in Form 1, somewhere in Form 1. Now, the other effect is that a force can make an object to turn about a point. We refer to this effect as moment of that force about that point. We refer to the turning effect of a force as moment of the force about that point. It's very important. You may find that sometimes I repeat things because I want them to get into your mind, because you may be hearing about moment of a force about a point for the first time, so I need to repeat it several times. The other way of understanding this particular concept is to play this video over and over again until that concept gets into you. So, how do we define moment of a force about a point? I've started this video by showing you a person who is tightening a nut using a spanner. A person who is tightening a nut using a spanner. You find that the nut turns about the bolt because the spanner is making it to turn. You may have experienced this, and you may have wanted to loosen a spanner. Maybe it's a very tight nut. What do you do when you want to loosen that particular spanner other than applying oil onto the nut? You find that you make the handle of the spanner to be longer. These are some of the things we are going to look at. We are going to ask ourselves, why do we do that? But before we go there, let's define the term moment of a force about a point as the product of the force and the perpendicular distance from the point to the line of action of the force. That definition appears to be quite complicated, but it is not. Let me break it down for you. Moment of a force about a point is defined as product. Product means multiplication. Multiplication of two physical quantities. Remember, derived physical quantities are those physical quantities which can be obtained from other physical quantities by either multiplication or division. If I go back, when you studied pressure, pressure is a derived physical quantity. It was obtained by dividing the force and the area on which the force is acting. How about moment? This one is the product of two physical quantities, force and the distance. Now, how are these distances oriented to each other? Okay, the distance must make 90 degrees with the line of action of the force. The distance must make 90 degrees with the line of action of the force. And let me explain using this diagram. There is this point here. This is the point about which the object is going to turn. This point, because objects always turn about a point. You know, this one is different from where a force is applied and the whole object moves. This is one where a force is applied at one point of the object and then that object twists. It does not undergo any kind of displacement, but what it does is to turn. Okay, so the object will have a turning point, just like when you open the door. It turns about the hinge. I'll be showing you that in a moment when we'll be looking at the direction of moment of a force about a point. So this is the point about which the object turns. The point about which the object turns. All right. This is the force that is applied in order to make the object turn. This force has a direction along which it is acting. It is referred to as the line of action of the force, the direction in which the force is acting. That line is referred to as the line of action of the force. And then there is the distance from the point about which the object is turning all the way to the line of action of the force. That distance is oriented to the force in such a way that the distance and the force, they make 90 degrees. The distance and the force make 90 degrees. This is very important. Once you have ensured that the distance and the force make 90 degrees, this is the time that you go on and multiply the two in order to get the moment of that particular force. So you may have to go through this definition over and over again in order to understand what it is. So it is a product of the force and the perpendicular distance. Perpendicular means 90 degrees. Perpendicular distance from the point all the way to the line of action of the force. So being a product, the equation which is associated with its definition is this one. Moment is equal to force times distance. But remember that distance must be perpendicular to the force, because if it is parallel to the force, what you will be calculating is not moment, but you will be calculating another physical quantity referred to as work. Work is given by the same equation, force times distance, but this time the force and the distance, they are parallel to each other. They are in the same direction. But when they are perpendicular, we are working out a physical quantity referred to as moment. Agreed? Good. Now, what is the SI unit of force and what is the SI unit of distance? This is very easy. The SI unit of force is Newton, while the SI unit of distance is meters. That means that the SI unit of moment is the product of the SI unit of force and the SI unit of distance. The SI unit of moment is the product or multiplication of the SI unit of force and the SI unit of distance. That is the Newton meter. Newton meter. Okay, Newton meter. Be careful here, it's not Newton per meter, but Newton meter. Newton per meter is the SI unit of another physical quantity we refer to as spring constant. So just be careful here. So what are the things to write down? On this slide, if you can pause the video, write the definition of moment, then draw this diagram that we have here. Draw this diagram with all the labeling clearly, and then write down this equation and this one here. And then, in order to understand this much clearly, you may want to ask yourself, how about if the force and the distance are not at 90 degrees to each other. Like for example, this distance of 5 meters is not at 90 degrees to the force. What do? You've got to look at the diagram carefully and see which distance to use. Because over here, you had a distance of 5 meters, which is perpendicular to a force of 200 newtons. The moment due to this 200 newton force about point O is the force itself, 200 newtons times 5 meters, and you get 1000 Newton meter clockwise. I'll explain why I'm using the word clockwise in a moment. But when it comes to this diagram, notice that the force and the distance, they are not perpendicular to each other. You've been given other distances here. After all, this triangle here is a right angled triangle, and by using Pythagoras theorem, if for example you are given this as the hypotenuse of the triangle, this is one of the sides of the triangle, you should be able to work out this length here as 3 meters and realize that the distance from the point, which makes 90 degrees with the line of action of the force, is the 3 meter distance. The moment due to the 200 Newton force about point O is given by 200 newtons times 3 meters, which gives you 600 Newton meter clockwise. Right? Now, let us look at these situations here, because I've mentioned the term clockwise, and I've mentioned, and you want to know why am I using that? Why is it clockwise? Or is there something we refer to as anti-clockwise? Imagine that you've got a clock. How does the arm of the clock move? Because I want you to compare it with the way the door is opening. You see, that door opens in that direction. Okay? How about the nut when it is being tightened using the spanner? Again, you can see that it is turning in that direction. Notice that the turning point is this point here, the center of the bolt, while the turning point for the door is the hinge. We are looking at the plan of the building. Okay, we are looking at the plan of the building. So what does it mean by clockwise? If for example, for some case, of course doors don't rotate like that unless it is a revolving door, but you can see that that direction is the direction in which the arm of a clock usually rotates clockwise. We are tightening the nut, so you can see that again it is turning in the clockwise direction. So when you want to know the direction of the moment of a force about a point, always ask yourself, suppose I were to put a clock here with the center of the clock at this point, what direction would be the arm turning? If it is turning in the opposite direction to the direction that we have here, we will refer to it as anti-clockwise. Okay, we're going to look at the anti-clockwise direction towards the end when we are looking at examples. Okay, now having understood that, let's look at factors affecting moment of a force about a point. And I'm going to use the spanner and the nut situation to describe these factors. We've got a force of 200 newtons turning that nut, tightening that nut about point O. So we want to calculate the moment due to the 200 Newton force about point O. And let's do exactly that. So I'm going to do some inking. So the moment due to the 200 Newton force about point O will be given by the force, which is 200 newtons times the distance of 0.4 meters. And you're going to see that this one is going to give me 80 Newton meters clockwise. Clockwise. That is the moment due to the 200 Newton force about point O. Let's look at this situation here. Now we've moved our hand so that the handle, the distance is increased. Let's again calculate the moment. Again, I'm going to use the symbol M to represent moment. So again, I'm going to have 200 times 0.8 meters. This is newtons. And I'm going to get 160 Newton meter clockwise. Observe that the moment has increased. The moment has increased. Now, why has it increased? What changes have we made to increase the moment? That is what should tell us which factor is affecting the magnitude of the moment. Because 160 Newton meter and 80 Newton meters, this is the magnitude of the moment. Clockwise is just a direction. So which factor has increased the moment of this force? Observe that the amount of force that I'm using remains the same. 200 newtons, 200 newtons. But here the distance is smaller and here the distance is doubled. When we double the distance, observe that the moment doubles. 160 is twice 80. So, perpendicular distance is one of the factors which affect moment of this force about the point. So we are going to say that moment is directly proportional to the perpendicular distance. Moment is directly proportional to the perpendicular distance. Direct proportionality between two physical quantities means that if this physical quantity is doubled, this one is going to double. If this variable, which is referred to as distance, is doubled, then the moment, which is affected by the distance, is going to double. So, one of the factors which affect moment of a force about a point is the perpendicular distance from the point to the line of action of the force. That is one of the factors. How does it affect moment? When that factor is doubled, moment will double also. When that situation, to describe that situation, we usually use the word direct proportionality, because if the distance is doubled, moment will double. So that is the first factor. Let's look at the next factor. This time we are going to keep the distance to be the same, 0.8 meters, 0.8 meters, but we are going to change the force. We are going to apply more force, 200 newtons, and here it will be 400 newtons. Again, you can pause the video, calculate the moment due to the 200 Newton meter and the moment due to the 400 Newton meter. And you'll find that the moment due to the 200 Newton meter about point O is 160 Newton meters clockwise in A, but in B, the moment due to the 400 Newton meter about point O will be 320 Newton meters again clockwise. So observe here that when the force is doubled, the moment doubles also. It's just like distance. When the distance doubled, the moment doubled. When distance doubled, the moment doubled. In this case, the force has doubled while distance is kept constant. And you realize that in part A, the moment due to the 200 Newton force about point O is 160 Newton meters clockwise, while in B, it is 320. 320 is double 160. Okay? So there are two factors which affect moment of a force about a point. These factors are force and perpendicular distance. How does force affect moment? If the force is doubled, moment is going to double. So we say moment is directly proportional to the force. The next factor is distance, perpendicular distance. If the perpendicular distance is doubled, then moment is going to double too. So moment is directly proportional to the perpendicular distance from the point to the line of action of the force. Now let's look at this particular situation here, where I require you to calculate. In fact, you can pause the video and calculate the moment due to each one of the forces about this point here. This point, you can call it point O, point O. As you do that, let's first of all see how you can determine the direction of each moment, whether that moment is clockwise or anti-clockwise. Let's look at the 100 Newton force, for example. In order to determine the direction of the moment due to the 100 Newton force about point O, this is what you're going to do. Number one, you're going to take the point about which the system is turning to be the center of a circle, and we are going to draw a circle where with the circumference or with the force being tangential to the circumference at this point. And that circle will be like that. It will be like that. Then at this point, we are going to look at the direction of the force. The force is tangential to the circle at this point. The force makes a tangent to the circle. The force makes a tangent to the circumference at this point. And since the direction of the force is downward, then we are going to put an arrow there on the circumference, and we are going to see that that force tends to turn the system in that direction. Another thing that you can do is to imagine, suppose the 100 Newton force was the only force acting on that object. In which direction will the object turn? And I've tried to simulate this so that you can see that force will tend to turn the system in that direction. Okay. How about the 50 Newton force? In which direction will it turn the system? Again, you draw a circle with this being the center, and the circle will go like that, in such a way that the circumference of the circle, the force is tangential to the circumference of the circle at this point. And when you look at the direction of this arrow, then the direction of the turning will be in the same direction like that. At least at this point, the circumference will have the same direction as this arrow. And you can see that the moment due to the 50 Newton force, if the 50 Newton force was the only force acting on that system, it will turn that object clockwise about that point. Similarly, with the 120 Newton force, you do the same. This circle will be quite big. It will be quite big, and you find that it's going to turn the system anti-clockwise about that point. So I'd like you to observe that in this particular figure, once you have worked out the moments, will be the moment due to the 100 Newton force about the point O is 300 Newton meter anti-clockwise. The moment due to the 50 Newton force about this point will be 2 times 50, which will be 100 Newton meter clockwise. And the moment due to the 120 Newton force will not be 120 times 5, because I know some students may have written that just because they can see this distance. What you have forgotten is that the distance is always measured from the turning point. Always measured from the turning point. So the distance will be 7. The distance will be 7, and that will give us 840 Newton meter anti-clockwise. So that's about the magnitude and the direction. How about the moment due to the 200 Newton force? This one is very simple. We just need to ask ourselves, how do we calculate moment? Force times distance. How much is the force from the turning point to the line of action of the 200 Newton force? how much is the distance from the turning point to the line of action of the 200 Newton force. Let me go back to this. How much is the distance from the turning point to the line of action of the 100 Newton force? You find that it is 3 meters. If I move this force over here, the distance will be about 1.5. If I move it over here, the distance will be 0.5. If I move it exactly at the turning point, the distance will be 0. So the distance from the turning point to the line of action of the 200 Newton force is 0. And that makes the moment due to the 200 Newton force to be 0. That concept is so important. Always check, does the line of action pass through the turning point? If it does that, then the moment due to that force about that point will be 0. That concept will be so important, especially when it comes to solving complicated questions where it's up to you to choose the point about which the system will turn. We will discuss and see that the most appropriate point for you to choose is the point where you eliminate an unknown force, and it is a force which is not required in the question. We will make use of that concept then when we come to such complicated questions. For now, I just want you to observe that the moment due to the 200 Newton force about point O is 0 because the line of action of that force passes through the turning point. The other thing I'd like you to observe is this. Forces can be on the same side of the turning point, like for example the 50 Newton force and the 120 Newton force. They are on the same side. They are on the right hand side of the turning point, but they turn the system in opposite directions. While the 50 Newton force turns the system clockwise, the 120 turns it anti-clockwise. So it does not follow that if forces are on the same side that they turn the system in the same direction. Not necessarily. Similarly, it does not follow that if forces are on opposite sides of the turning point that they are going to turn the system in different directions. For example, 50 Newton force turns it clockwise, while the 100 Newton force turns it anti-clockwise, and they are on opposite sides of the turning point. That is not always the case, because let's look at the moment due to the 120 Newton force about point O and the moment due to the 100 Newton force about the same point. You find that the 120 Newton force turns it anti-clockwise, while that of the 100 Newton force also turns it anti-clockwise, although they are on opposite sides of the turning point. So treat each force, treat the direction of each force independently. The other thing I want you to be careful about is that the distance that you use for each force must be measured from the same point. So you need to practice on this, because many times I've seen students make mistakes with this concept, because when they think about the turning effect or they think about moment, all the time they jump to the principle of moments, even if the principle of moments is not being applied. They have not fully digested how to calculate moment of a force about a point. So in the video description, you will go there, you will download, there is an exercise I've given there supporting all these points that we've discussed in this video. First of all, you'll go through this video again and again and again in order to understand each and every word that I have said here. And if by chance I've made a mistake, or maybe I've mentioned something which is not correct according to the diagram, just put it in the video description so that even other students can be able to see where I made the mistake and you're alerting me on that particular mistake. Okay? At the same time, in the comments, you can write the kind of challenges you have in going through that exercise. Okay? Because without exercising, there is no way you can test that you've really understood this concept. So the exercise I've given you is about how to calculate the moment due to a force about a given point. The point about which the you're supposed to take moments may change. That means the distances are going to change and so forth. So do exactly that. Go to the video description, download that exercise, and then if you've not subscribed to my channel yet, it's time for you to subscribe, because once you subscribe, if I make a new video, you will be alerted and you'll be able to see it, and then you'll be able to learn concepts from there. This is very important that you subscribe so that you are alerted each time I make a new video. And besides, when I want to post new materials, I will post it to those people who have already subscribed. So make sure that you have subscribed. You may also go ahead, in order to help this channel grow, you may also go ahead and share this kind of video with your friends. Discuss the kind of concepts which are there and let me know any difficulties that you're encountering. Otherwise, I want to stop there, and then I'll see you in the next video where I will be talking about the principle of moments, which is something which I know many students have been waiting for. The principle of moments. See you in the next video.